I am going to start with the function part of things and make a connection right here. Easier to follow that way. Geometric will save for later. Did we write this? This is important. It will come back in 11.2. Without the general term or the nth term, you cannot find the sum of the series. Okay. Good. I have one of those. Another. Good. Sine doesn't have any bound. I'm sorry, take that back. Sine doesn't have an asymptote. So, assume that it is a properly, nicely drawn sine wave. That has three functions. One of them is 1 over x. Which one? The first one, right? Okay. One of them is e raised x. Second one poorly drawn sine. Good. So these functions are continuous. Do we agree? Continuous functions. Now, instead of looking at all possible real numbers, in other words, going from 0 all the way up to infinity, what I'm rather going to do, start at n equals 1 and jump to 2, 3, and so on. Good. So n equals 1 would mean this function will give me a value of, let's start with x is equal to 1. If x is equal to 1, what would the value of the function be? When x is equal to 2, what would the value of the function be? 1/2. When x is equal to 3, 1/3. X is equal to 4. X is equal to 5. You get the point. Yes. But is this an arithmetic sequence? The red dots and
Yes.
has a common difference here. Are we sure? So between 1 and 1/2, it's 1/2. 1/2 and 1/4, a quarter of it. Right? It's 1/4, it's a quarter. So they don't have a common difference. Yes? Not an arithmetic sequence. The red dots. Same function. I'm simply going to draw it in a different way. Instead of that, good. 1, 2, 3, 4. Dots. N would be the individual values. I'm going to give it a name. You can pick a letter. B, C, D, E, F, G.
H.
Pick a letter from B, C, D, E, F, G. G, okay. G, I know H comes after G, you know. So G sub n, and I want to come up with the general term for that sequence. Do we agree that that is a sequence? Yes. Do we agree that this sequence is not an arithmetic sequence? Yes. Good. But I want to write the general term. Well, where did I get these points from? As I changed these values, Raphael simply gave me when x is 1, plug in 1, I get 1, 2, 1/2, and so on. So as a sequence, this would simply be g sub n 1 over n, common. Oh, semicolon. 1, 2, 3, dot, dot, dot. Good. So the general term of that sequence is 1 over n. N equals 1 is going to give me 1, n equals 2 would give me 1/2, n equals 3, 1/3, n equals 4, 1/4, and so on. Good. Okay. Should we start at 0 or 1? This one. Started at 1, so the next curve, should we start at 0 or 1?
0.
0. Okay, I like that. So when n is equal to, or when x is equal to 0, what is the value of the function? 1. Good. When x is equal to 1, what is the value of the function? E. 2.7818, right? When you put in 2, you get 2.78 squared, 7.89 approximately. And when it is 3, you are going to get 61 something. So e raised 1, e raised 2, e raised 3, yes? Just plugging in the value for x. So as a sequence, n starting at 0, 1, 2, 3, dot, dot, dot. 0, e squared, e cubed. That is the sequence. So I'll have the general term here. I'll use h. H sub n is e raised n 0, 1, 2, 3, dot, dot, dot. Again, where you start n masses. I did that last time. If I plug in 0, I'm going to get 1, plug in 1, I get e, plug in 2, e squared, plug in 3, e. Good? One more, we'll read it. So sine x. I want you to give me the sequence representation of sine x based on whatever we did with that one and that one. We'll pick a letter from B, C, D, E, F, I, J. Well, let's ignore I, J, K, L, N. I just made it way too difficult. Let's go back a bit. Pick a letter, B, C, and D. B, okay. So I want a sequence notation for that. In other words, I am going to pick points. Let's say we will start from 0.
Sine of n.
So Caleb says b sub n equals sine n.
It has to be sine n pi.
Red round my Caleb. I mean, cut. But I'm going with what Caleb said, sine n. Go ahead, Caleb.
Well, I was actually gonna say like there should be a pi maybe. We were.
No, we're going to go with sine n first. We're starting n equals 0, 1, 2, and so on, right? Okay. Now, going to Cartier's question. Shouldn't there be a pi? And Caleb acknowledged that there should be a pi. Why is that? Why does that pi matter? Unit circle, it's periodic, and all that. Now, if you simply put in 0, 1, 2, 3, you're arbitrarily picking points on this wave. It's not defining the sequence properly. But if you want to go at a certain step or with a certain step, in other words, pi over 3, move in steps of 30 degrees, right? Or move in steps of 45 degrees, then there has to be a pi term of some sort. So instead of simply calling it n, running out of letters, G, B, C, C sub n equals sine n pi, and I'm going to define n equals 0, 1, 2, 3, dot, and you can tell me which points I am picking from that function. So n is going to start at 0, and I would like to know which points I am picking from that function. As I vary n, put it in that sequence, I'm going to grab points from that curve. What points am I picking?
0, pi, 2 pi.
So that's over here, right?
Yeah.
So it should be 0, pi, 2 pi. So what would the corresponding C values be?
0.
Every single one of them would be 0. Do we agree? Good. If I didn't like that one bit, let's say I want to go in steps of pi over 3. Let's do pi over 6, 30 degrees. Good. How should I change this? In other words, I need to pick 30 values at every 30 degrees. So 30, 60, 90. How about this? Think of the sequence 0, 30, 60, 90, 120. That should tell you how to get. Okay. Are we clear as to what we did here? Yes. There. Okay. That's okay. One more, and then I'll go to the calculator. 0, 30 degrees is pi over 6, 60, pi over 3.
It's n pi over 3.
Very good. So all I have to do is make one little change. Instead of n pi, I'm going to put n pi divided by 3. Good. If I put in n pi divided by 3, I'll call d sub n sine n pi over 3. N equals 0, 1, 2, 3, and so on. When n is 0, I'm picking that point. When n is equal to 1, I'm picking sine pi over 3. Sine pi over 3 is, oh, sorry, pi over 6. Sine pi over 6 is 1/2. I just let it slide, okay, that's whatever. You said pi, n pi over 3, then pi over 6. What is it? When n is equal to 1, you get 1/2. When n is equal to 2, root 3 over 2, 0.8. When n is equal to 4 pi over 3, where will I be?
1/2.
Right there, yes. And the next point, and I would simply pick those individual points. Does that make sense? So, whatever we do with functions, and simply be extended to the series. By all means, real life deals around sequences. Very good example. Do we take pictures with your phone? Do we know what a pixel is? Each individual value is some sort of a sequence. If you look at the edge of your face, it follows a sequence or a path, but it doesn't follow in a continuous way, it follows in a discrete way. I'm standing here speaking to you. The words that I say is actually a waveform, but you cannot simply fit a function directly, rather you've got to approximate it infinitely. In other words, you've got to sample it at infinite points. Does that make sense? So in other words, instead of having simply n pi, if I sampled it in a way that I have thousands of points, eventually I have a nice little curve. Do you agree? Yes, no, maybe? Okay, that's called sampling, way outside the scope of this course. But every single sequence that I generated here comes from a function. Good? And that's it. Grab your calculator. I'll show you how to do this. Before we get to that, this function has a limit. Yes? But is that function bounded? No, the function is not bounded. But is the sequence bounded? Yes, because the maximum value that it can reach is right there. The bounds are 1 and 0. Yes, it can't equal 0, it will approach 0. Okay, is that function bounded? It's ongoing to infinity. Is that sequence bounded? No, it keeps on going toward infinity. This is not a bounded sequence, has a lower bound, doesn't have an upper bound. This case right there, is that a bounded sequence? Yes. By all means, the maximum value that it can reach is 1. The minimum value that it can reach is -1. But per our definition there is no way that it is going to reach 1 and -1. The maximum bound that it can reach is
Pi over 3.
come again?
Pi over 3.
No, that's you're looking right here at the angle, right? I'm asking for the y value. So sine is between -1 and 1, so that sequence -1 and 1, but it's just going to give us 0, so that's bounded for sure. My question is the n pi over 6 function. It is bounded, but it is not bounded between -1 and 1. Sine n pi over 6 sequence. What are the two bounds? It's not -1 and 1. Hint, it's in the picture. It has something to do with x's. They all live in Texas. No one got that joke. Moving on. So 0, 1/2, root 3 over 2, root 3 over 2, 1/2, 0, -1/2. negative root 3 over 2, negative root 3 over 2, negative half, 0. So the bound that it can reach, lower side, is negative root 3 over 2, upper root 3 over 2. Does that make sense? Okay.
What's the answer? Like, you did all these other mini equations using like sine and this. What's the answer?
I'm explaining what a sequence is.
Oh.
Right, I started with a regular arithmetic sequence. I explained why the general term matters. I explained what would happen if you write it the wrong way. And I explained the value of n where you start matters. Then I came to this section where I wanted to demonstrate what the limit of a sequence is and what the bound of a sequence is. To that end, I simply started with functions because we know limits and bounds of functions. If I simply picked arbitrary integer values, I can write the same function. That's great. The only difference being that's continuous. Those are sampled points. This is a sequence of numbers. So the sequence of dots that you see here is generated by that general term. That general term and that function, they look pretty much the same, right? So in a functional form, if you want a continuous function, you would write this as sine pi times x over 6. You will get a nice little curve of some sort, right? But if you put it as n pi over 6, you are picking individual values, and where are those values coming from? There. Good. When that plot, it would make sense, yes.
So does x correspond with n?
Yes. X is continuous, n is discrete. Good. So grab your calculator and put it in sequence mode.